So the task we've been given is to create a method that takes in two numbers and returns the result of one number raised to the power of the other number. So for an example, if we pass in a 2 and a 3, it would return 8. 3 and a 3 would return 27, etc. I've got it started with our class. I've decided to call it EXP and our main method. So let's create the method that's actually going to do the work here. Remember, a method has two main parts. What are they? Header and a body, correct. And how do we start out the header? Int, right. We're going to return an int. I didn't specify what data type to use. Int is a fine choice. And what do you want to call it? Exponents works. And it needs to take two arguments. They can be of type int as well. And what do you want to call them? That's fine. Good. If names are helpful. Okay. Now what I'm going to do is I'm going to create a local variable to store the answer. So that's also going to be an int. And I'm going to call it answer. And I'm also going to initialize it to 1. And we'll see why it should be initialized to 1 in just a moment. Now, as we talked about, the best way to solve this problem is with a loop. You have three different types of loops to choose from. What are they again? While loop, do while loop, and the for loop. Correct. You could use any one of them. You could make any one of them work. Which do you think would be the best choice? I would go with a for loop because we know exactly how many times it's going to repeat as determined by this variable, the exponent. Okay, so we'll start our for loop. We need a counter variable for our for loop. I'm going to initialize it to 1, and it's going to count up to expo and increment by ones. As a side note, that's how C++ got its name. There was a language called C, and C++ was the next iteration of C. Okay, so now what we want to do is we want this answer to be multiplied by what? The base. And keep multiplying itself by the base for as many times as is equivalent to that expo, which should be as how many times this loop repeats. So that would look something like this. Answer equals itself times base. And then after the loop is done, you need to return that answer. And we'll delve deeper into that loop in just a moment to show how that works. Now, just to test it out, I'm going to go back to main and just put in a print statement. All right, let's compile it, run it. 2, 3 gives us 8. Looks correct so far. You always want to try a few different values. 3, 3, 27. Now, where things sometimes go awry is when we get close to the bounds. In other words, what happens if we have an exponent of 1? The answer should be 3, and it is. And what happens if we have an exponent of 0? What should the answer be? 1. And it is. So let's delve deeper into this loop and see how it was able to do that. So I started off initializing the answer to 1. Now let's look at this case that we have right now. The base is 3 and the exponent is 0. So we come to this loop. This variable c starts at 1, and it's going to repeat as long as c is less than or equal to expo. Well, right now c is 1 and expo is what? 0. So that evaluates this expression to what? False. So this loop, these instructions in the loop do not repeat at all. They don't get executed. So therefore, answer remains 1, and that gets returned back to main. Okay? What happens if 1 is the exponent? Well, let's come down here. So answer is initialized to 1. C starts at 1, and we count to 1. So this line gets executed 1 time. Answer equals itself times base of 3, so answer becomes 3. And for anything higher than that, the loop keeps repeating until it reaches that value of expo. So 3 to the 4th power is 81. Questions? No? All right, let's take a look at, we'll have a quick lecture finishing off the new material in chapter 5, and then tomorrow we'll start a group project. As soon as PowerPoint comes up here. Oh, all right. PowerPoint's not working. Ending the broadcast.